All right, in today's video, we're going to talk about arrays. And as you notice here, I have a little drawing program out because we have to talk before we start coding on our circuit playground. We are going to talk about what they are a little bit theoretically first. So last time we talked about variables. And remember that we mentioned that variables were basically like boxes, right? So if you remember that we had a light when we made the Cyclone arcade game, right? We had a box, we had a variable, and that box had light position on it, right? Light position, that was the name of the variable. When we asked the computer what was the light position, and if the light position was at 3, well, the computer opened the box, looked inside, and gave us the number 3. And then, of course, it would either light up or turn off the pixel at light position number 3. All right. An array is slightly different. It's sort of a list of variables, right? A long list of variables. It could be, well, it doesn't have to be long. It could just be one. It could be none. Not usually, but it could be you can have an array that's empty. Or it could be infinite, theoretically infinite. Of course, an array can only be as big as the memory in your computer. But long story short, it's going to be a list of numbers or characters or whatever you want instead of just one thing. So let's make that a little bit more clear. So we have one box that we would refer to as a variable. With an array, we're going to imagine that it's a much bigger box, right? And let's imagine for now, let's not talk about light position, but let's imagine that I'm an animal lover. I have tons of pets at home and I want to make an app because I'm a pet lover, but also I'm a programmer. And I want to make an app to keep track of all my pets, right? Their names, their medical information, whether they've been tagged or not, stuff like that, right? So I could, if I didn't know what an array was, I could make a new variable for every pet that I had. So pet1 could be a box, and I could put the pet's name in there. So pet1 could be my dog, and his name is Rusty. And pet2 could be my goldfish, and her name is Flounder, and so on and so forth. But the problem with making a new variable for something that I know I'm going to have a lot of is, well, there's two major problems. Number one, if I make 20 variables, because I have 20 pets, the day that I get a new pet, or the unfortunate day that one of my pets dies, I have to manage adding and subtracting new variables, making and deleting variables, right? Which means I'm probably going to have to go back into my code and change that. But usually when you make an app, you want the app to be able to add and take, create things and take things away on its own. So you're kind of limiting yourself if you're just going to make something a new variable. And the other problem is you're going to have to keep track of all of these new variable names, right? Pet1, pet2, pet3, pet4, and all of their connections between each other. If you know you're going to have some long list of something, an array is the perfect thing. It's what you're going to want. So instead of having pet1, pet2, pet3, we might have an array called pets, which instead of just one box, we can think of this as, or one small box, we can think of pets, the array, as a big box with a bunch of variables inside of it. Except the unique thing about these variables they aren't just boxes, right? If we look inside of this box, or if the computer looks inside of this box, what it's going to find is, yes, a bunch of boxes, one for every pet that I have, right? Except these are chained together in an order, right? And the most important thing to remember about these is their order always starts at 0. There's one thing you remember about this video. It's that arrays start counting at the 0 position. So the first thing we put in our array is going to be in position 0. So that's my dog, Rusty, right? My goldfish flounder is here, and my hamster, who's named Chuckles, is here, right? Now, there's a couple of other things that we're going to really have to talk about arrays, but I want to pause there because I don't want to load on too much too fast. But just remember, for now, a variable is a single box. We put a name on it. We ask what's in that box. It's just going to be one thing, a number, a character, a letter, whatever. But it's going to be one single thing. When we have an array, a big box, smaller boxes inside, which we can then open and see what's inside, which in this case is Rusty, right? So just to see if we're following along here, I'm going to ask you a question. Let's forget about pets for a second. Let's say I have an array, and in this array is called alphabet, or in this case, just alpha. And inside of my alpha array is the alphabet, right? So we look inside, we see 26 boxes. There's 26 letters in the alphabet, in case you didn't know. I'm not going to draw all 26, right? And of course, in this position, we have A and B and C and so on, right? There we go. So my first question is, if we remember the one thing I asked us to remember, my first question is going to be, what is in position number 4? Yeah, pause the video. Think about that for a second. Think about what is in position number 4. If you answered E, then you are correct, right? Because we have at 0 is A, at 1 is B, at 2 is C, 0, 1, 2, 3 is D, and at 4 is E. I don't know why I went from lowercase to capital there. Here we go. D and E is at 4. So E is the 5th letter of the alphabet, but because we started counting at 0, we get E in position number 4, always one less, because we start counting at 0. Now, if you didn't get that one right, try to think about this one. Dot, dot, dot. Now the last box here. My last box, of course, in my alphabet array is going to be Z. Which position is Z going to be in? There's 26 letters of the alphabet. Pause the video, come up with your solution, and then go ahead and play again, and I'll reveal the answer. All right. Now, if you said 25, then you are correct, because we started counting at 0. There's 26 letters in the alphabet. Z is going to be at position 25. All right. So let's stop talking about variables for a second. There's a lot more to say, but we'll come back to this in a moment. First, let's see how an array is going to affect our programs compared to variables, right? So we are going to make a portion of a game, right? If you've ever played Simon Says, all right, it's a little plastic toy. It's got 4 lights on it, red, green, blue, and yellow. And you boot it up and it starts immediately, right? And it'll play one of those 4, it'll light up one of those 4 lights and play like a note for one of those lights. And if blue lights up, it'll stop, and then it'll wait for you to put in your answer. And if you put blue, then its turn goes, and then it'll play 2 lights. The first one that it played, and then a new one. So then it'll say maybe like blue, green, and then it'll wait for you to do blue, green, and so on and so forth. And it'll keep doing that until you get one wrong. So we could probably come up with a Simon Says type game, probably a much harder one, right? We have 10 lights, so we can make this much harder. Now, let's imagine that we have that to-do list, right? We always want to create to-do lists now for our programs. So we have a to-do list of that Simon Says game, and of course it's going to have a lot of different things on it. But one of the things it's going to have is that we need to make the lights come on in a sequence so that the player knows what they're supposed to put in. So one light at a time, and then let the player go. So we're going to do that, but we're going to make it really simple. We're just going to go up to 3. So the first thing that we need to do is get rid of forever. Because remember that we're lighting up some lights and then waiting for the player to go. We don't want to loop them over and over again like our Cyclone game going in a circle. So we're going to throw away our forever loop, and we're going to just say on start. And then we're going to light up a pixel color. And we'll do that 3 times. And we'll make them different lights. So let's say 4, then 8, and then 1. If we look at our program, we already see our first issue. We have 4, 3, and 1 all lit up at the same time. The point is that they're supposed to light up and then light up one at a time and then show the player. So, our next instinct might be to go ahead and put in a pause and make this maybe 1 second between each one. And now let's see what that does to our program. All right, they light up one at a time, but they don't turn off. So that's not good. They should definitely be turning off as well. So I'll copy the 4, make it black. Copy the 8, make it black. Copy the 1, make it black. And put a pause in between all of those as well. Now let's watch our program go. There we go. Now we know we're supposed to light up this one, and then this one. 4, 8, and 1. All right. Wonderful. Except for a few problems, right? So I've coded what I want. So in terms of the to-do list, you could say I'm done. It's not the greatest game in the world. We only have 3, but there's more problems in the fact that we only have 3, right? We repeat our code way too much. You could see that this would be very hard to maintain if we wanted to make this game go forever. We would have to code it forever. And even if we were going to use variables, which we definitely could, we'd have to create a new variable for each new number in the sequence, right? Sequence number 1, sequence number 2, sequence number 3. You can call those variables whatever you want, but the problem is we'd be limiting ourselves, like I said before, with our pets. So if I wanted to make 20 of these sequences, then if the player who's going to play my game is good enough at this game that they get to 20, they're going to get bored of my game very quickly, because then it'll never go above 20. They'll never get to go to 21, 22, 23. So then I say, all right, fine, I'll update my game so that you can play it. Now I go from 20 to 40. Well, I'm going to be chasing my own tail there, because they're going to be able to get better and better and better. And I'm always limiting my program, right? There's always somebody out there who's going to be smart enough, clever enough, have a good enough memory to beat my game, right? So I can't limit myself like that. So let's look at how we can edit this program using an array. So what I can do now is we're going to make our very first array. So if you're following along, let's go ahead and call this memory lights, right? Remember that usually we're going to have an S at the end of our arrays, because plural, we're going to hold multiple things. So we have memory lights as our first array. And notice that I made it a variable. Arrays are basically variables. They're just a fancy variable. So when I set memory lights to something, I'm not going to set it to any particular number. I'm actually going to set it. We're going to go into advanced here. Click arrays. And at the beginning of our program, we're going to set it to an empty array. Now, the next thing I'm going to do doesn't have anything to do with arrays, but see this pause here? I hate having a pause and then the number and the same number and the same number and the same number. So we're going to remember our best practices when it comes to variables, and we'll create a variable for this called delay. we'll set delay to 1,000 and put delay in each one of these boxes here. So delay, delay, and so on and so forth. So now that I have my empty array for the light variable, the memory lights variable, I can go in and add a new value, right, for each number that I want to put in here. So at 0 and at 1 and at 2, right? Remember, we're lighting the circuit playground up 3 times. So the highest number in this array is going to be 2, because in the 0 position is going to be our first number, then 1, then 2, for a total of 3. So now I'm going to set this to 4, 8, and then 1. Four, 8, and 1. And this is, of course, all going inside of memory lights. So now I have an array called memory lights. And in the first position, which is the 0 position, I'm putting a 4. And in the second position, which is the 1 position, I'm putting an 8. And in the third position, which is position number 2, I'm putting in a 1. So now I can say, instead of these numbers, I can reference my array. So let's see what that looks like. Now we're going to get list value, get value at, and this of course is going to be memory lights. And we're going to have 0, 1, and 2. And now I can put here and here, here and here for 1, and here for 2. And now my program should do the same thing it did before. Now we really didn't do anything new or anything fancy here. It's just as much code. If anything, it's longer now because I had to set the values up here and then also down here. But what's great now is I can affect these numbers, just like how with delay, this variable allows me to change this number. You know, I can make the delay longer, or I can make the delay slightly shorter. Maybe 1 second was too long. And I've changed all of these with just 1. Same thing here. I can now go, instead of 4, let's say it's 3, 9, and also 1. So now I can change those lights and what they light up just by changing them here instead of all here. So that's good. But we could do even better, right? With the memory lights, one thing about Simon that's fun is that they aren't the same number every time, right? You're eventually going to remember the sequence if you just have 391, 391, 391 every single time. So this is a great time to go ahead and have our pick random, right? So we're popping these numbers out of here, having pick random. Of course, 0 to 9, there is no 10 pixel 10 on this. Now, every time I restart my program, I get random lights. See, 0, 8, 7, is that 5, 5, 4, 5, 5, 4. So now I have a much more fun game because I used pick random. Okay. Now we're going to make this even better here in a second, but let's go back to our chalkboard and visualize what we just did, right? So at the very beginning of our program, we created an array. It was empty, right? But we so we basically created a big empty box. And on the front of that box, we called it memory lights. I don't have enough room to write here, so I'm just going to do mem lights. All right. And in our memory lights box, there is nothing at first, right? So we ask what's in there and we don't know. There's nothing in there. Computer has nothing to return. But later in the program, in the 0 position, right? We pick a random number, 0 to 9. And then in position 1, right? That's 0. That's 1. We have another random number, 0 to 9. And in the third position, which of course is position 2, we have another 0 to 9. And if we ask the computer what's in there, it'll pick a random number, 0 to 9, let's say 2. We say, okay, there's 2. There's 2 in position 0. So remember, 2 is what's in the box. 0 is the number of where it is in its position. Okay? It's a little complex, but bear with us here. So this is how we're going to visualize it. Chain of boxes inside of a big box. All right. So let's go back to, and actually one thing that's really important to remember, that here is the label on these boxes is their position, right? Technically speaking, it's what I showed up here. Oh, I never wrote this. Okay, so let's write that. So when we start typing code, an array is usually typed out like this, right? When we ask for a specific position, right? We'll say memory lights, and then a bracket, a square bracket. And if we wanted to know what's in 0, we would say memory lights 0. And this is the name that goes on the box. So that's memory lights 0, that's memory lights 1, that's memory lights 2. And if we wanted to know what's at memory light 0, that's when the computer goes and opens that box and finds the random number 0 to 9, which in this case was 2. Okay. But this is the label. This is the label right here that's on each one of these boxes. Right? You don't get to name these boxes individually. The computer's automatically going to give these a name. You only get to name the array, not the individual boxes in the array. Okay, so let's continue on back at our program. Here's our program here. Slightly better because we have our random numbers. And we're not hard coding those numbers into here, but we can make this better. For example, we're repeating ourselves a lot for only 3 lights. Look at all this code. So what we're going to do is we're going to slim this down a little bit. We're going to slim this down using a loop, right? Whenever you see a lot of repeated code, we love to use loops. So we're going to break all of this down into just wherever its unique code was. So notice that we repeated this 3 times. So I only want one of them. And we repeat this chunk, right, from the red to the delay under the black. We repeat this chunk 3 times. So let's throw away all the rest. We're going to get out a loop, a very special loop. You may not have used this one before. This one has this little pink sort of pill in it. If we remember what the pink pill is, that is a variable. I want you to think for a moment what this variable might be. If we're looping from 0 to 4, what might that variable be? It's called index. This variable is keeping track of how many times we've looped. So when we loop the first time, index is 0. And when we loop the second time, index is 1, all the way up to 4. So this loop actually loops 5 times. Again, we start counting from 0. So this loop loops 5 times 0 to 4, and index changes every time we loop. And you're going to see why that's so important. We're going to loop our unique code here. I'm going to put a pause on that for a second. Now, here's another question for you. If we want this to loop 3 times, what goes in this number? The answer is 2, right? Because we're going to do 0, 1, 2 for a total of 3 times. And then when we loop, right, we want to put in the array at position 0 a random number. And the first time we loop, we want to put it at the 0 position, right? Then we want to light up the pixel at the 0 position. Then we want to turn off the light at the 0 position. And then when we loop, we want to do it at the 1's position. And then when we loop again, we want to do it at the 2's position. So that's why this variable is so important, because it allows us that every time we loop, we can just add 1. It's almost like having a variable that adds 1 every time, except it's made for us. So now when I play this, it should do exactly what we want. 3 lights, 1 at a time, and it's random every single time. And that's it. So the last thing we're going to do is I'm just going to break this down from start to finish, because one of the best ways to learn code is to read the code from start to finish and try to understand what it does. So at the beginning of our program, we create an array. On start, we create an array called memory lights, and that array is empty, right? So we have our big box, but it's empty. And in that box is memory lights. We set another smaller box, right? And in that box is called delay, which I'll just put DEL because I won't be able to fit all that. And in that box, we have the number 1000. Remember that what's in that box is not 1000 milliseconds. What is in an array never really has any context until you use it. So sometimes I'll ask students what's in delay, and they'll tell me it's 1000, or I guess in this case it's 700 milliseconds. Well, it's not. It's only 700. When we use delay in this block, now it's 700 milliseconds because that's what that block is. But if we use delay accidentally in a score, in the context of a score, it would be the score 700. Of course, that would be our fault. We made that mistake, but that's important to know, that the computer doesn't really know why you're using the variable or what you're using it for, only that you're using it. So we made delay 700, and when we use it later, it'll be in the context of milliseconds, but we'll get there when we get there. Next one is for. So I have this fancy for loop, and it's got this variable called index, which keeps track of how many times we're in the loop. So the first time we're in the loop is the first time we're using it. The index is equal to 0. So every time we see index, we're going to open up an index box. So now we have another box, right? This box is called index. And every time we open this box, we're going to find where we are in the loop. It's 0 right now. We go to the memory lights box and we set the value at index. So index is 0, like we just said. So now we're opening the memory lights box, and inside the memory lights box at 0, we're stuffing in a number 0 to 9. let's say we're putting in the number 2. Goes in the box. Okay. Then we're going to set the pixel color at memory lights get value at index. So we're getting the value at 0, which is what's in this box. So I'm telling the computer to open up the memory lights box, then open up the box at position 0. What's inside? 2. So we're lighting up, 0, 1, 2. There we go. We're going to light that up as red. Then we're going to delay. We're saying open up the delay box. What's inside? 700. Pause for 700 milliseconds. Set pixel color 2. Open the memory lights box. Get value at what's an index. So I'm saying open up the index box, right? Which is 0 right now. Open up the box at 0. What's inside? 2. So we turned on 2. We turn off 2. Pause. Open up the delay box. What's inside? 700. Go back. Index is now 1 because we're at the top. We looped again. Index is at 1. Open up the memory lights value. Put inside the 1 position a random number. 0 to 9. Let's say it's 9. Set the pixel color at, open the memory lights box. What's inside the value at index? Open the index box. It's 1. What's in the 1 position? 9. Right? Go to 9, which is here. Light it up red. Delay. Open that delay box. What's inside? A 700. We wait for 700 milliseconds. Now we set the pixel color 2. Open the memory lights box. I'm asking for the value at. Open the index box. 1. I go to this 1. What's inside? It's 9 again, of course. So we turn off the 9 pixel. Wait. Open the delay box. 700 milliseconds. We do that one more time. Index is now 2, the last number in my loop. Open the memory lights box. Open the index box and find 2. We're putting in a number, setting a value. Setting a value at index, which is 2. Picking a random number 0 to 9. Let's say it's 1. So I put in 1 here. Set pixel color at. Open the memory lights box. Get value at index, which is 2. What do we find in there? It's a 1. We turn on 1. We delay for 700 milliseconds. We do the same thing again. What's in the 2 box? It's a 1. We turn off 1. We wait 700 milliseconds. That's the end of the loop. This loop doesn't loop again because it's just on start, so it only does it once. That's the end of our program. Whew. All right. I know it's a lot. You might have to watch this video multiple times. That's okay. You might have to make many, many arrays until we completely understand what they do. But what is the number one thing I asked us all to remember? That is, when do we start counting our arrays? We start counting them at 0. We count our arrays at 0. So if I want 5 things in my array, the lowest number will be 0. The highest number will be 4. 0, 1, 2, 3, 4 for a total of 5 things. All right. As always, I hope this video helped, and I will see you in the next video.